Hi, this is a CBSE XII Physics 3-mark question. The question reads, two identical parallel plate capacitors C1 and C2 have capacitances C each. The space between their plates is now filled with dielectrics as shown. If the two capacitors still have equal capacitance, obtain the relation between the dielectric constants K, K1 and K2. So the key concepts which will be used are capacitance of a parallel plate capacitor is given by A epsilon naught by D, where A is the area of the plates and D is the distance between the plates. And if two capacitors are connected in parallel, then the net capacitance is given by C1 plus C2. So here, if A is the area of cross-section of the plates, then C1 and C2 value will be A epsilon naught by D. Now, if C1 dash is the capacitance of the first capacitor after the material is filled, and C2 dash is the capacitance of the second capacitor after the two materials are filled, then C1 dash is equal to C2 dash that is given to you. Now we'll find the value of C1 dash and C2 dash. C1 dash will be K A epsilon naught by D because the material is completely filled. Whereas C2 dash, this is equivalent to two capacitors which are connected in parallel. So we have to find first the capacitance of those individual capacitance. If we represent the capacitance of those capacitors by CK1 and CK2, then C2 dash will be CK1 plus CK2. CK1 value will be K1 A by 2 epsilon naught by D because of the area of cross section is just half. Similarly, CK2 will be K2 A epsilon naught by 2D. And C2 dash will be the sum of the two will take common A epsilon naught by 2D K1 plus K2. And when we equate the two, we get A epsilon naught by D is A epsilon naught by 2D K1 plus K2. A epsilon naught by D cancels and we get K is equal to K1 plus K2 by 2 or 2K is equal to K1 plus K2. So this is the relation between the three dielectric constants. Hope the problem is clear. If you want to see my further videos, kindly subscribe my channel. Thank you.